Доброго дня, шановні колеги. Членів спеціалізованої вченої ради я прошу включити камери. Дякую. Юрій Васильовичу.
Добрий день.
Добрий день.
Добрий день.
Добрий день.
Добрий день.
Добре чути, видно. Це гаразд.
Так.
Так, видно.
Так, видно, добре.
Доброго дня, шановні колеги. Я всіх вітаю на сьогоднішньому дійстві, яке присвячено захисту дисертації нашого аспіранта Катаєва Дениса Анатолійовича. Захист по спеціальності 175 інформаційно-вимірювальні технології. Шановний пане Денисе, якою мовою ви бажаєте проводити захист?
Бажаю англійською.
Добре. Шановні члени разової спецради, чи всі згодні на те, щоб наш захист проводився англійською мовою?
Yes.
Yes. Згодні.
Так,
Дуже дякую. Тому розпочинаємо наше сьогоднішнє засідання і проводимо його англійською мовою. Dear members of Council, dear attendees, in accordance with the procedure of award the Doctor of Philosophy degree and revoking the decision of one-time specialized academic council of Higher Education Institute or Research Institute on awarding the Doctor of Philosophy degree, hereinafter referred at the procedure of the Ministry of Education and Science, approved by the resolution of Cabinet Minister of Ukraine number 44 of January 12, 2022, and the General Energy Institute of the National Academy of Science of Ukraine by order the director dated August 5, 2025, number 23, one-time specialized academic council, DF 26.223.03, was established with the authority to review the conduct the one-time defense of the dissertation of Denis Katayev for the purpose of awarding him the Doctor of Philosophy degree in the field of knowledge 17, electronics, automation, and electronic communication. Specialty 175, information and measurement technologies. Composites of the one-time specialist academic council. Chairman of the council, Svetlana Kovtun, Doctor of Technical Science, Senior Researcher, Deputy Director of Scientific Affairs of the General Energy Institute of National Academy of Science of Ukraine. I am present. Reviewers, Yuri Kuts, Doctor of Technical Science, Professor, Leading Researcher at the Department of Monitoring and Diagnostic of Energy Facilities, General Energy Institute of National Academy of Science of Ukraine. Are you present?
yes.
Okay. Next, Igor Bogachov, candidate of technical science, senior researcher fellows at the Department of Monitoring and Diagnostics of Energy Facilities, General Energy Institute of the National Academy of Science of Ukraine. Are you present?
Yes.
Okay. Official opponents, Petro Reiter, Doctor of Technical Science, Professor of Department of Information and Measurement Technologies and Energy Management, Ivano-Frankivsk Institute of Oil and Gas. Are you present?
Yes, I am present. Present.
Okay. Next official opponents, Maxim Bondarenko, Doctor of Technical Science, professor, head of Department of Instrumentation, Mechatronics and Computerized Technologies, Cherkasky State Technology University. Are you present?
Yes, I'm present.
Good.
Yes, yes,
Good. Good. I'm here.
yes. Listen me.
Yes, we hear you. In accordance with the requirements of the procedures of the Ministry of Education and the Science, the meeting of the one-time council for the public defense of the dissertation is conducted according to the procedure defined by the institutions. At the meeting of the Academic Council of the General Engine Institute of the National Academy of Science on March 9, 2023, protocol number 4, the procedure for the meeting of the one-time specialized Academic Council for conducting the public defense of a dissertation for a doctor of philosophy degree was approved. According to clause number 28, the procedure of the Ministry of Education and Science and the procedure, the meeting of the one council time is considered authorized provided that all members of council are present. Given the presence of all members of the one-time council, I declare that the meeting is authorized. A quorum is present, and I declare the meeting open. Agenda. Consideration of the dissertation by Denisa Katayev for the degree of Doctor of Philosophy in the field of knowledge 17, Electronics, Automation and Electronic Communication, specialty 175, Information and Measurement Technologies. Title of dissertation: Software and Information Complex for Improving the Accuracy of Measurement of Geometric Parameters of Power Equipment parts based on a neural network. Scientific supervisors, Doctor of Technical Science, Senior Researcher, the projects Artur. Foreign member of National Academy of Science of Ukraine, Doctor of Technical Science, Professor Kabczyk Janusz. The documents in the certification file submitted by the applicant in accordance with the procedure of the Ministry of Education and Science meet the established requirements. Especially they include a copy of master's diploma, which states that Denisa Katayev graduated from the National Aviation University in 2020 and ended the qualification master's degree in the specialty Power Engineering, Electronic Engineering, and Electromechanics. An academic certificate confirming the completion of the educational and scientific program Information and Measurement Technologies in Energy. The dissertation in both printed and electronic formats. A positive conclusion by the scientific supervisor, Doctor of Technical Science, Senior Researcher Artur Zaporozhets, and Doctor of Technical Science, Professor Janusz Kabczyk. A positive conclusions on the scientific knowledge, theoretical and practical significance of the dissertation results. Science by the chairman of the extended meeting of the Department of Forecasting, the development of the electronic power complex, director of the Institute of General Energy of the National Academy of Science of Ukraine, academician of the National Academy of Science of Ukraine, Vitaly Gapa. This conclusion is provided without any remarks. Copies of 6 scientific publications that highlights the scientific result of the dissertation certificated by the academic secretary. A certificate on the result of the academic integrated check of the dissertation manuscript, a hard copy of the review of the dissertation by Yuri Kutz, which is positive, with remarks. A hard copy of review of the dissertation by Igor Bogachev, which is positive, with remarks. A hard copy of review of official opponent's patrol writer, which is positive, with remarks. A hard copy of review of the official opponent's Maxim Bondarenko, which is positive, with remarks. The topic of dissertation was approved by Academic Council of the General Energy Institute of the National Academy of Sciences of UK on December 26, 2024, protocol number 20. Information regarding the acceptance of the dissertation for consideration, the electronic copy of the dissertation, and the review of the official opponents and reviewers signed with the electronic signatures was been published on the official website of General Energy Institute. Are there any questions for the council members regarding the information presented? No, there are none. Thank you. The floor is given to Denisa Katayev to present the main points of his dissertation. The time limits up to 20 minutes. Please.
Okay, thank you. Good day, dear colleagues. This is presentation based of result of the dissertation research for obtaining the degree of Doctor of Philosophy, specialty 175, Information and Measuring Technologies. The topic of dissertation is software and information complex for improving the accuracy of measurement of geometric parameters of power equipment parts based on neural networks. Scientific supervisors, Doctor of Technical Science, Senior Researcher Artur Zaporozhets, Foreign Member of the National Academy of Science of Ukraine, Doctor of Technical Science, Professor Janusz Kapsz. The energy sector is one of the keys for ensuring the stable functioning of modern society. Reliability, efficiency, and safety of power equipments directly depend on the accuracy of manufacturing and compliance of parts with standard and technical requirements. The use of modern information and measurement system allows achieving high measurement accuracy, but has a number of limitations, including insufficient adaptation to the impact of external destabilizing factors. The relevance of the work is due of the need to reduce the existing limitation and consist of development of a software and information complex with integrated neural networks, the implementation of which in information and measurement system based a coordinate measuring arm will significantly reduce the impact of external destabilizing factors, which will increase the accuracy of measurement of geometric parameters of power equipment parts. Domestic and foreign scientists have made a significant contribution to the development of resolution of these issues. Academical of National Academy of Science of Ukraine, VP Babak, and also scientists, VP Kvasnikov, DP Ornatsky, J. Sladik, B.I. Newman, Yan Cheng, Zhao, and others. The object of study is a process of measuring the geometric parameters of power equipment parts. The subject of the study is methods, models, and means of improving the accuracy of measurement of geometric parameters of power equipment parts based on neural networks. The aim of the study is to improve the accuracy of measurement of geometric parameters of power equipment parts by developing a software and information system with an integrated neural network. To achieve this goal, it is necessary to solve the following task. to analyze the existing method of calibration of the CMA and to propose a solution that combines the advantages of known methods for systematic consideration of destabilizing factors and compensation of typical kinematics error. Develop a method of compensating for residual kinematics error that will improve the accuracy of the CMA measurements. To propose the structure of a software information complex with a neural networks for further integration into IMS based on coordinate measuring arms. Research and improve machine learning algorithms for further integration for neural networks into the software and information complex. Develop software of neural networks constitution, calibration, and data processing. To create and analyze test models of neural networks and experimentally justify the choice of model for integration into a software and information complex. The coordinate measuring arm is widely used in the energy sector, is particular of the production, repair, maintenance, prototyping, and reverse engineering as a means of high precision measurement of geometric parameters of power equipment parts. Due to its design, flexibility, and mobility, the CMA provides the ability to work with complex objects in production conditions, which helps to accelerate the creation of new components and allows for the efficient restoration of worn components and systems. In production condition, the measurement process is affected by a large number of destabilizing factors, which leads to errors that can be divided into kinematic and non-kinematic. The analysis of literature source has shown that most studies focus primarily on compensation of kinematics error, while non-kinematics error are either ignored or considered in simplified form. Non-kinematics errors are complex nature and can change over time and operating condition, which makes it difficult or impossible to compensate for them using standard mathematical methods. Thus, the development of a software information system with an integrated neural networks for calculating and compensating for non-kinematic errors open up new opportunities. To effectively compensate for non-kinematic errors, it is proposed to implement a process of stepwise error compensation using classical and intelligent method. At the first stage, after applying the kinematic model to convert the segment angles into proper coordinates, typical kinematic errors are identified and compensated using the combined calibration method. At a second stage, the residual kinematic errors are compensated using the single point correction method, which in turn allows identifying the residual non-kinematic errors components, which are further compensated using neural networks. In the practice of CMA calibration, the most commonly used test is the effective diameter test, which is standard method recommended by leading manufacturers such as Faro, Hexagon, and Romer. Despite its widespread use, this test can compensate mainly for systematic displacements, orientation errors, and mismatches length, but doesn't provide a complete pictures of the system kinematic errors. To improve the calibration accuracy, it is advisable to use a combined method that combines the capabilities of the test. Effective diameter test to correct for systematic offsets, orientation errors, and link length mismatch. Single point measurement test that provides correction of proposition errors, detection of backlash encoder errors, and volumetric measurement test that provides correction of kinematic errors within the full operating range of the CMA. The combined calibration method provides comprehensive coverage of the metrological characteristic of the CMA, allowing to effectively compensation both linear and angular components of systematic errors of the CMA. So the compensation of the residual kinematic errors is carried out by the method of single point correction of residual errors. For a number of CMA configuration, the deviation between the actual and the reference position of the endpoint is measured. Based on the data obtained, a polynomial model is built that describes the dependence of the error of the angular parameters of the link. This model is used to correct the coordinate of the course of the measurement, which reduce of residual kinematic errors in the entire working volume of the CMA. To evaluate the effectivity of the single point residual kinematic errors correction method, a simulation was performed as a result of which the root mean square deviation of the endpoint position. This case is interpreted as a quantitative assessment of the residual kinematic error, decrease from 0.58 millimeters to 0.14 millimeters. To further compensate for the non-kinematic components of the error, they also propose to integrate a software information complex with neural networks into the software structure of the CMA. The software and information system consists of the following components. One Y on K function of the software information complex is the error compensation model, which implements an approach to eliminating residual non-kinematic error. For this purpose, a neural network is integrated to provide adaptive data processing. As a result of the analysis of the mean architecture of neural networks, it is proposed to use neural networks with an error propagation algorithm to compensate for the residual non-kinematic errors. Since the effectiveness of such a model largely depends on the choice of hyperparameters and the activation function, it is advisable determine the values experimentally. To select the activation function, we conducted an experiment with 4 standard functions. A separate neural networks model with the same architecture was created for each function. The training process of synthetic data covered 100 epochs, and each of 100 iterations. The mean square error was chosen as a loss function. The results of the study are present of the form of a graph illustration, the average values of test loss for each of the activation function. The best performance was demonstrated by the ReLU function, which provided the lowest average MCF values during the training cycle. To investigate the impact of hyperparameters on the performance of neural networks, 432 combination of typical K hyperparameters were generated. A separate model was created for each configuration and trained of synthetic coordinates. The models were preliminarily evaluated by the frequency of correction, the number of times the predicted coordinates fell outside the confidence intervals. Models with zero frequency were classified as stable. Among them, the greatest reduction in uncertainty was demonstrated by model 127 with the following hyperparameters. Number of neurons, 64, learning rate, 0.001, number of epochs, 100, sorry. Mini packet size 64 and the regularization 0.001. After determining the activation function and the required hyperparameter, the neural networks was trained on a synthetic set of coordinates. For this purpose, the calibration procedure was modeled with a sphere with a diameter of 30 millimeters of the surface of the 1000 points, were generated using a uniform distribution in order to simulate the influence of non-kinematic errors. 500 noisy values generated by a normal distribution were added to these coordinates. This dataset was created reflects the impact of destabilizing factor that occur of a real production environment. The neural networks model is trained on the data and then used to predict the coordinate of the test points. After the neural network's training stage was completed, the calibration procedure was simulated using the effective diameter test from the noisy coordinate. 10 test points were selected or test or input of the neural networks. The result correct coordinates were compared with the initial to values to assess to the effectiveness of the correction. The obtained result showed that 9 out of 10 points coordinate corrected by neural networks approached the surface of the reference sphere. Thus, the use of the calibration procedure with CMA allows to reduce the residual non-kinematics error, estimated by RMSE from 0.8 millimeters to 0.14 millimeters. This indicates the effectiveness of the combination of classical and intelligent methods implemented within the software and information complex, aimed at improving the accuracy of measurements of geometric parameters of power equipment parts. Scientific novelty. A universal calibration method is proposed, which consists of using 3 calibration standards within one procedure, which makes it possible to take into account systematic error in surface sensors, to access the ability of the CMA to stably reproduce the same point in space, and to determine the parameters of the reproducibility in the linear movement of the CMA. A method for compensating for the residual kinematic error using a single point model of residual error correction has been developed, which has made it possible to reduce the kinematic components of the residual errors by a factor of 4. The training theory of the neural networks was further developed, which made it possible to automatically take into account variable measurement condition and compensate for the influence of destabilizing factor, which made it possible to reduce the non-kinetic components of the residual errors by factor of 6. The structure of information and measuring system based on the use of special software and information complex. With an integrated CMA to improve the accuracy of measurement of geometric parameters of power equipment parts is proposed. The software information system has been developed that allows for calibration, data processing, training of CMA, and improvement of the accuracy of measurement of geometric parameters of power equipment parts. 432 modifications of neural networks were created to analyze the data of measurement of geometric parameters of power equipment parts, and the choice of the optimal neural network model was substantiated, which allowed to take into account the variable measurement condition and compensate for the influence of destabilizing factors. On the topic of the dissertation, 6 scientific papers revealing of the main content of the dissertation were published in 4 and Ukrainian professional journals, 3 publications of conference proceedings. The result of research were implemented by and used by Avatech LLC Kyiv and Ecolux LLC Kyiv. In the dissertation, a scientific and technical problem of improving the accuracy of measuring the geometric parameters of power equipment parts has been solved. The main result of the research are as follows. The calibration procedure for coordinate measuring arm has been improved through the use of a set of calibration standards, enabling effective compensation of typical kinematic errors. A method for compensating residual kinematic errors based on polynomial model has been developed, which allowed reducing the error by a factor of 4. A software and information complex incorporating a neural networks for the correction of non-kinematic errors has been proposed. The choice of neural network architecture has been obtained, resulting in a 6-fold reduction of non-kinematic error. Thus, the dissertation contributes to improving geometric measurements, accuracy of power equipments, and supports further research in information and measurement system under variable condition. Thank you for your attention.
Мікрофон, Світлана Івановна.
Thank you. Thank you, Mr. Katayev, for your presentation in the hand time. Let's move on to the discussion. Estimate members of the council and guests, please introduce yourself when asking a question. Question can be asked in oral or written form. I remind you that all council members must ask questions. So, with your permission, I will begin. Mr. Katayev, estimate dissertation. So your work mentions a collaboration method using 3 standards. Could you please explain in more detail why 3 standards and not, for example, 2 or 4 are considered the optimal number of standards?
Thank you for your questions. One standard, for example, a calibrate sphere only allows for the assessment of the local accuracy of contact probing. However, this test provides no information about the stability of measurements in space or the reproducibility under condition of variable orientation. 2 standard sphere and a 3-hedral triple socket allow for the calibration of probing accuracy and the stability of single-point measurement in a fixed position. However, this leaves the errors of use of the probe's trajectory uncontrolled, particularly those that arise when moving through a volume such as deflections, torsional, distortional, and inertial effects. A third standard above in introduction to evaluate accuracy within the volume of space across a set of orientation and distance. They allows for the detection of errors related to the probe's movements in 3-dimensional space, increasing the number of standards beyond 3. Complicates the calibration procedure without providing a proportional increase in accuracy. I finished.
Okay, thank you. And next question, please. Your dissertation concerns improving the accuracy of measurements of geometric parameters specifically for energy equipment parts. Can the software and information complex be applied in other industries, such as aviation or automotive manufacturing, without significant modification?
Thank you for questions. Also, the dissertation is focused on energy equipment. The core principle of error compensation using neural networks are applicable to any field where measurement accuracy is crucial, such as aviation, robotics, and mechanical engineering. To adapt it to another industry, it will be necessary to retrain the neural networks on the relevant experimental data.
Thank you. I'm satisfaction. Who is next?
With your permission, dear colleagues.
Yes, please, Yuri Vasilievich.
Yuri Kuts, Doctor of Technical Science, Professor. First question. What are the units of measurement of the parameter who's shown on slide 16? Specialty, learning rate, mini batch size, and regularization.
Just a second. Learning rate, batch size, and regularization are dimensionless quantities. The learning rate is a multiplier that determines what fraction of the found direction of change gradient should be applied to update the weights. The mini batch size is the number of examples from the training set that are processed simultaneously of one training step. For example, if the batch size equals 64, the network updates this parameter after analyzing 64 values. Regularization is an additional coefficient that is added to the loss function, where the weight values become too large. It is needed to prevent the model from becoming too complex and overfitting the training data, thereby losing its ability to generalize.
Okay, thank you. And the second question, please tell us about your vision for further research in this field. What steps do you consider most important for further improvement?
Thank you for the question. The further development of this research of the development of adaptive learning algorithm that would allow the network to learn and correct errors of real time. This would enable the complex to automatically adapt to changing operation conditions without requiring retraining.
Okay, thank you. I am satisfied.
Thank you.
Thank you, Юрій Васильович. Next up to Ігор Багачов, please.
Thank you. Esteemed Denis Anatoleyevich, my first questions. You used the Denavit-Hartenberg kinematic model. In your work, you mentioned that the head's limitation when the joint axes are paralleled or near paralleled. How did you solve this problem?
Thank you for the question. To overcome the limitation of the classic Denavit-Hartenberg model, a modified model was used in the work. The modified model eliminates singularities by redefining the coordinate system for each manipulator elements. This ensures a correct and complete representation of the kinematic scheme of the measurement complex, which is essential for the subsequent compensation of errors.
Thank you. I am completely satisfied with your answer. My second question. The work mentions use a method of simulate the influence of destabilizing factors to generate synthetic data. Can the data obtained from a simulate be considered sufficiently reliable for training a neural network that will then work with real production conditions?
Thank you for the question. Synthetic data generated based on mathematical models allows for the creation of a controlled environment where various types of errors can be simulated. The successful training of neural networks of this data proves that the chosen architecture and algorithms are capable of effectively detecting and compensating for non-linear dependencies. Model training on synthetic data serves as a universal prototype. It is a ready-made foundation that can be quickly adapted to a specific production environment by retraining it on real-world data. This saves time and resource as it eliminates the need to start training from scratch.
Thank you. I am satisfied with answer. There are no questions.
Thank you.
Thank you. Now questions from the official opponents. Who will be next?
Good day, colleague. Thank you. I have two questions. First question is, I would like to hear your justification for choosing a neural network architecture for compensation of kinematic error. Why was a neural network with the backpropagation of error chosen to compensate for error and not, say, a recurrent one or CNN network, for example?
Thank you for question. The key argument against using recurrent architecture is that the data obtaining does not have the time dependency characteristic of, for example, forecasting or single processing task. The main advantage of backpropagation neural networks is its ability to learn complex non-linear relationship between input and output data. This is especially important because measurement errors caused by vibration, temperature, and other destabilizing factors are non-linear. Backpropagation neural network can approximate any continuous function with arbitrary accuracy. This means the network can learn the complex function that describes measurement errors, regardless of the nature. This makes the BPNN a universal tool for tasks where precise mathematical models is unknown.
Thank you. I am satisfied with your answer. My second question, slide number 23, mention as the implementation of result at the enterprise. ADA, tech, and ECO like us. What especially did the collaboration involve?
Thank you.
On the document.
The implementation of the developed calibration method of the enterprise Avatech and Ecolux made it possible to increase measurement accuracy, which in turn allowed for a reduction in the percentage of defects and environment in the quality of the final products.
Thank you, understood. Thank you, I am satisfied. Okay.
Thank you.
Thank you. Maxim Alexeyevich, the floor is yours.
Thank you. My first question. The work mentions that the software and information complex can effectively compensate of the influence of destabilizing factors such as vibration and thermal deformation. How exactly does the neural network distinguish and react to each of these factors individually?
Thank you for the questions. The software and information complex, which is based on neural networks, does not distinguish and compensate for each factor separately. Instead, it learns from the combined influence of all destabilizing factor. The neural networks identify the general pattern of errors that arise under the influence of external conditionals and based on this correct the measurement results. This allows for the simultaneous compensation of both vibration and thermal deformation without the need for further individual modeling.
Thanks. The answer is clear. Now for the second question. Does your system provide the possibility of scaling and adapting to other types of measurement setups?
Thank you. The system is designed of a modular principle where each component performs its own function. One module is responsible for the kinematic model, another for training the neural networks, and a third for visualization. To adapt the system to a different setup, it is sufficient to retrain the neural networks of data obtained from the new system. In the case of a measurement setup with a different kinematic scheme, only the kinematic models need to be updated. This ensures the system flexibility, allowing it to work with a wide range of equipment.
Thank you for your answer. There are no questions.
Thank you.
Thank you. Are there any more questions?
Not.
There are no questions, and in our chat also. Then we will move on to the review and feedback on the dissertation. Before the discussion, I would like to remind the council member that since all review and feedback have been posted on the Institute's website, and are positive, there is no need to read them in the infinitely. Please consider the comments and suggestions from the reviewers and official opponents. The floor is given to the reviewer, Yuri Vasilievich Kuz, Doctor of Technical Science, Professor, and Leading Researchers Fellow. Please.
Thank you. Esteemed Denise, I would like to know that your dissertation is a complete and independent scientific study in which you successfully fulfilled the set scientific task, the development and information complex to improve the accuracy of measurement of energy equipment parts. However, as with any research, I have a few remarks which nevertheless do not diminish the scientific value of your work. 1. In the second chapter of the dissertation, the author describes the development of a kinematic model using the Vandenberg parameters. It would have been appropriate to provide a more detailed justification for choosing this special model, considering alternative methods of kinematic modeling. For example, models based on finite element method or alternative kinematic models with few parameters. It would also be appropriate to analyze the advantages and disadvantages of the proposed method in comparison to other approaches. 2. In the third chapter, the author presents a detailed structure and algorithm of the development software and information complex. At the same time, the issue of integrating this complex with existing industrial automated quality control systems for parts requires additional explanation. It would have been appropriate to highlight the main technical and software requirements for such integration, particularly the issue of data transfer protocol compatibility. 3. In the fourth chapter of the dissertation, the methodology, the preparing data of training neural network is considered. The author hasn't given sufficient attention to justifying the choice of special methods for normalization and generation of synthetic data. It would be necessary to more clearly indicate how these approaches affect the overall training efficiency and the accuracy of the obtaining results, and also to conduct a comparative analysis of different data preprocessing techniques. 4. The dissertation doesn't sufficiently cover the influence of external conditions, such as temperature fluctuations, vibrations, electromagnetic interference, etc., on measurement accuracy after compensation by your neural network. It would have been appropriate to provide additional experimental data on the behavior of the proposed software complex under conditions of significant environmental changes, which is an important factor for evaluating the stability of measurements in production conditions. And 5. Although the dissertation contains a significant amount of illustrative material, certain results of the experimental studies are presented mainly in the form of tables. It would also have been appropriate to provide a graphical comparison of the accuracy of the proposed complex with existing analogs or traditional methods of error compensation, which would allow for a more visual assessment of the advantages of the proposed approach. And regarding the conclusions, I believe that in terms of its relevance, scientific level, substantiation, and degree of implementation of the results, the dissertation meets the requirements. Thank you for your attention.
Thank you for your
That's
comments.
all.
Regarding the first point, the choice of Deniss-Hartenberg parameters for kinematic modeling was justified by the widespread use and standardization in robotic and measurement technology. Compared to alternative methods such as model based on the finite elements method, the Deniss-Hartenberg method is more computationally efficient for tasks related to kinematic error compensation. This was a key factor for cleaning the software and information complex. Regarding the second comments, the issue of integrating the complex with existing industrial system was addressed during the architecture development stage. The developed complex has a modular structure which allow it to be easily adapted to different systems. Regarding the third comments is developing the methodology for data preparation of the neural network, data normalization, and synthetic data generation method were considered and selected. The min-max normalization method was chosen because it ensures data in scale to a single range from 0 to 1 or from -1 to 1, which is optimal for most neural network activation function and prevents future with larger values from dominating. The generation of synthetic data was applied to increase the volume of the training sample and to improve the neural network's resistance to small variation of the input data, which is typical of real production condition. Regarding the fourth comment, I agree that providing additional experimental data which are detailed analyzed for the complex behavior under extreme environmental change is important for a comprehensive evaluation of measurement stability and can be subject for further research. Regarding the fifth comment, I completely agree with you that the graphical representation of result allows for a more visual assessment of the work's advantages, while the dissertation gave significant attention to tabular representation graph would have been more informative. Thank you for your comments. They are valuable for the further improvement of my works. Thank you. Microphone.
Yuri Vasilievich, are you satisfied with that?
Yes, I am completely satisfied with the answer. Thank you.
Thank you. The floor is given to the reviewer, Igor Bogachev, candidate of technical science, senior researcher. Please.
Thank you. Just a few words about relevance. The relevance of Deniss Katayev dissertation is determined by need to compensate for no-kinematic measurement errors caused by external factors such as temperature changes, vibration, and electromagnetic interference, which cannot be eliminated by standard calibration method. Therefore, the development of software and information complex using neural network to compensate for such errors is timely and important task. Here is the translation of the review comments and conclusion. First, in the dissertation of the calibration algorithm, chapter 2, the author proposed using exactly 3 standards. It would be worthwhile to provide a more detailed justification for this number of standard is optimal, and how change the number of standard can affect calibration accuracy and complexity of the procedure. Second, in chapter 3 of the dissertation, the author provides detailed justification for the choice of neural network architecture and present result for a significant number of model variants. However, it would be appropriate to state in the text of the dissertation what the specific type of neural network were chosen and why the possibility of using the promising type of network, such recurrent ERNN or conventional CNN, which could be further increase the accuracy of error compensation, was not considered. Third, in chapter 4, the analysis of neural network sensitivity to variation in individual hyperparameters, number of layers, number of neurons, layer rate, etc., is not sufficiently covered. In the recommended to provide deeper analysis of the influence of the parameter of the accuracy and stability of the neural network training. Fourth, in the chapter 5, when describing the results of neural network training, it would be appropriate to add additional graphical dependencies that would clearly demonstrate the dynamic of change in network accuracy and convergence process during training. Fifth, in the chapter 5, the result of experiment studies on the effectiveness of proposed software and information complex are presented only the specific type of activation function. Additional explanation is need for why more extensive comparative analysis of effectiveness of using different loss function and their influence on the final accuracy and training speed of the neural network was not conducted. Six, the work does not give sufficient attention to issue of developed complexes performance, particularly the influence of neural network data preceding time on the overall productivity of the measurement process, which is important for practical use of the developed solution in real production conditions. And the conclusion. The dissertation by Denisa, Katayev, Software Information Complex for Improving the Accuracy of Measurement of Geometric Parameters of Energy Equipment Parts based on neural network is completed scientific work that solved important scientific problem significant for development of methodology for prices measurement in industry. The main result of dissertation are fully reflected in publications, were described at conferences, and were appropriated at scientific seminars. I believe that Denisa Katayev deserves to be awarded the degree of Doctor of Philosophy in specialty 175, Information and Measurement Technology. Thank you. I am done.
Thank you. I am grateful for your comments. They are very valuable for improving my work. Regarding the first comment, the choice of three standards for calibration is justified from the standpoint of balancing accuracy and procedural complexity. Three standard allows for obtaining a sufficient amount of data for reliable calibration without excessive complication of the process. Regarding the second comments, the use of other types of networks such as recurrent neural networks or convolutional neural networks was not considered because they are primarily intended for working with sequential and spatial data, for example, image time series, which does not correspond to the specific of our research. Regarding the third comments, the analysis of the neural network sensitivity to hyperparameter variation was concluded through experimental research, the result of which are presented in the dissertation. It was established that the number of layers and neurons in them as well as the learning rate significantly affect the accuracy and stability of training. Regarding the four comments, I completely agree that the graphical representation of training result is very informative. To visualize the training dynamics graph could have been used. The world have allowed for a clear demonstration of the convergence process and confirmation of the absence of overfitting. Regarding the fifth comments, the choice was made in favor of mean-square error because it is the most common and effective for regression task. And regarding the sixth comment, I agree with your comment. The issue of the complex speed is very important for the practical implementation of the development solution. The aspect was indeed given in sufficient attention in the work. Thank you for your very good comments.
Are you satisfied with the answer, Igor Volodymyrovich?
Yes, completely satisfied. Thank you.
Thank you.
Thank you. And then next, the floor is given to the official opponents, Petro Anatolійович Reiter, Doctor of Technical Science. Professor, please.
Thank you. I prepare the review in the form which need, but now shortly describe which point of the scientific novel scientific and my recommendation. Dear colleague, I consider it necessary to note that, in general, dissertation work has a high scientific and technical level. However, during its analysis, several comments and recommendations were identified that should be taken into account to improve the quality of this work. First, the introduction, the page 10 during the set, author provide information on the practical significance of obtained result, but does not specify concrete quantity indicators of the economic or production efficiency of implementing the developed complex at enterprises, which could have significantly strengthened justification of the practical value of the research. Second, the first chapter, page 15 during the 27, presents an analysis of modern approach to error compensation, but lack a detailed comparative analysis of the advantage and disadvantage of this method, which could have better justified the choice of the neural network-based approach. In the second chapter of dissertation, at the page from the 28 to the 35, dedicated to building a kinematic model of coordinate measuring arm using the Denisa Harvard parameters, insufficient attention is paid to analyzing the model's sensitivity to change in initial parameter, which is the key importance for evaluation the stability and reliability of the measurement result under real operation condition. Fourth, in the third chapter, page from the 64 to the 78, process of creating of neural network model is described, but insufficient attention is paid to justifying the choice of the optimization method and stopping strategy for the neural network training process, which I think that important for the ensuring the efficiency and reproducibility of the result work. In the first 5 recommendation number 5, in the fourth chapter, the page from the 95 to the 102, algorithms for generating synthetic data set are proposed. Very interesting method for generated, but the influence of the quantity and type of noise on the quality of neural network training is not considered. An analysis of such an influence would have significantly increased the applied value of the obtained results. And last recommendation 6, the dissertation pays insufficient attention to the analysis of potential risk and limitation of applying the developed software and information complex under condition of the significant environment change. For example, extreme temperature fluctuation, vibration, etc., which could have significantly increased the practical reliability of proposed solution. And as conclusion, I would like to note that Denisa's Katayev dissertation is performed at a high scientific level and is a complete scientific study that has significant importance for the field of knowledge 17, namely electronics, automation, and electronics communication. The dissertation work, in terms of its relevance, practical value, and scientific novelty, fully meets the requirement current Ukrainian legislation. Thank you. I think that this work is very interesting in the methodological direction, and I can see many interesting points in this work. Thank you. I have finished.
Thank you for your comment. I agree that the introduction does not give enough attention to a specific quantitative indication. This is because the work is primarily of scientific and research nature. In the first chapter, a review of modern methods was conducted by agreed that a detailed comparative analysis of the advantage for disadvantage of different approach called have been expanded upon. Indeed, an analysis of the model's sensitivity to initial parameter is important for evaluating its reliability. Within the scope of the dissertation, the model was tested using various set of initial data, which allowed users to be confident in the stability of the results. However, I acknowledge that a more detailed quantitative sensitivity analysis, for example, using Monte Carlo method, could have significantly strengthened the justification for the reliability of the proposed approach and could be the subject of the further research. When developing the neural network model, the adaptive moment estimation optimization method was chosen because it is one of the most effective and popular in machine learning. The early stopping strategy was used to prevent overfitting, which allowed the model to retain its generalizing ability and achieve optimal results. Regarding the effect of noise of the quality of training, thank you for this comment. Studying the effect of different types and amount of noise of the training quality is important and can be included of future works. I'm completely agree that the works does not give enough attention to the analysis of potential risk and limitation. Thus, the neural networks was trained on data from different conditions. Detailed analysis of this behavior under extreme and environmental change would allow for assessment of the complex application limits and the development of additional adaptation mechanism, which is one of the key directions to future research. Thank you for your comments.
Thank you. Are you satisfied with the answer, Anatolійович?
Thank you. I have very detailed describing every
Thank you.
recommendation, and I am satisfied with the answer. Okay.
Thank you.
Thank you. The floor is given to the official opponent, Maxim Alexeyevich Bondarenko, Doctor of Technical Science, Professor, please.
Well, thank you. Denis Kataev's work demonstrated a high level of scientific training as the author applied advanced method of artificial intelligence, which confers his ability not only to master new approaches, but also to effectively use them to obtain significant scientific results. All the results obtained in the dissertation are logical, consistent, and justified, both theoretically and practically. The experimental parts and performance correctly, and the conclusions and results are reliable. The author has all the necessary publication, including scientific articles and conference papers. It is also worth noting that the work has practical significance and evidenced by the presence of implementation acts of the obtained results. Now, for the shortcoming. First, in the first chapter of the dissertation, page 25 to 28, tables 1.1, 1.2, are provided that describe the factors causing kinematics and non-kinematics errors, but there are no references to specific literary sources, which would have significantly strengthened the author's arguments. Second, when considering mathematical model for error compensation, pages 27, 32, specific numeral examples of error calculations are absent. Providing them would have allowed for a better assessment of the practical effectiveness of the proposed approaches. The second chapter, pages 38-42, describe in detail the kinematics model based on the Denic-Hartenberg parameters, but lacks graphical materials, for example, diagrams of 3D visualization, which would have greatly facilitated and understanding of this model. Fourth, in chapter 3, section 3.3, pages 76-80, the use of Python and libraries like PyTorch, NumPy, SciPy, etc. for developing the software complex is noted, but the technical characteristic of the hardware used for training the neural networks are absent, which is important for evaluating the system performance and scalability. Fifth, In chapter 4, section 4.1, pages 83-89, methods for generating synthetic data for the neural network are described. But there is no comparative analysis of the obtained synthetic data with experimentally obtained real data, which could have additionally confirmed the correctness of the proposed approaches. Sixth, in the experimental chapters 5, pages 105, 110, 35, the presentation of graph illustration, the dynamics of the neural network's training process, for example, the dependencies of training and tensor error, is insufficient, which would have provided a more detailed understanding of the network training effectiveness. And last, the work as a whole lacks a separated subsection that would clearly define the limitation of the applied method and outline specific directly for future research, which could have significantly extended the work prospect. Well, now for the conclusions. I believe that the dissertation work is performed at a high level, meets the requirements of qualified scientific works for the degrees of Doctor of Philosophy, and is also Denis Anatoleyevich Katayev deserves to be awarded the scientific degree of Doctor of Philosophy in the field of knowledge 17 and his specialty 175, information and measurement technologies. Thank you. That's all.
Thank you for your comments. I'm grateful for the detailed analysis of my dissertation. I agree that the lack of reference to sourcing table 1.1 and 1.2 is a shortcoming. The information present in these tables is a generalization of the result of the analysis conducted on the basis of the procedural literature, but direct reference to specific work would have indeed strengthened the argument. Also, providing specific numerical example of error calculating the chapter of mathematical models would have made the material more illustrative and would have allowed for a better assessment of the practical effectiveness of the proposed approaches. I fully agree that graphical materials such as diagram of 3D visualization will have significantly facilitated the perception of the complex kinematic model. Although the model of describes in detail a visual representation would have helped to better understand in structure and the relationship between the data with hardware parameters. Regarding the absence of hardware specification, I cannot the choice of Python software and the PyTorch, NumPy, and SciPy libraries was due to their efficiency and popularity for machine learning tasks. The comment about the absence of technical specification for the hardware is valid as the information is important from the reproducibility of the experiment and assessment of the system performance. The neural network was trained on a standard personal computer with an Intel Core i7 processor and an NVIDIA GeForce and RTX graphics accelerator, which provided sufficient performance for data processing. I agree that a comparative analysis between synthetic and experimentally obtained real data is important to confirm the correctness of the generated method. Although synthetic data was used to simulate real condition, a deeper analysis of the similarity between the two datasets would have significantly increased the applied value of the obtained results. Your recommendation to add graphs that illustrate the dynamics of neural networks training is very appropriate. graph of the training and testing error dependencies of the number of the epoch, the standard practice for visualization training effectiveness. Their inclusion of the dissertation would have provided a more detailed understanding of the training process, the network convergence. I agree that I would have been worthwhile to add information about the limitation of the applied method to the work. This information is important because it allows for an understanding of the limit of the developed complex application and provides clear guidelines for further developments. Thank you for your comments. I am grateful for your contribution to the improvement of my work. Thank you.
Thank you. Maxim Alexeyevich, are you satisfied with the answer?
Yes, I am satisfied. Thank you.
Thank you. I noticed that no comments or inquiries have been received from outside organization. In accordance with the Ministry of Education and Science regulation and the procedure, each member of the one-time council must openly express their position for or against awarding the Doctor of Philosophy degree to Denisa Katayev. Who would like to speak first? Yuri Vasilievich, perhaps you? Please.
Thank you. I completely agree with the assessment provided by the reviewers and opponents. I support this work and vote for awarding Denis Anatolievich the degree of Doctor of Philosophy.
Thank you.
Thank you. Igor Volodymyrovich?
I fully support this work. Of course, there are some shortcomings, but the main thing is that there is good prospect for developing this topic. I support the work and vote yes.
Thank you.
Thank you. Petro Mykolaevich?
I also support this work. The work is extremely relevant and very important in now and important not only in the direction of scientific, but in the direction methodological. For during next researcher, for example, mathematical model and software have been developed. I support this work and will vote in the favor.
Thank you.
Thank you.
Thank you.
Maxim Alexeyevich?
Well, I support this work. Denis Anatolievich Katayev has demonstrated all the necessary competences. His work meets the requirements and contains significant scientific and practical results. Therefore, I also vote the awarding Denis the degrees of Doctor of Philosophy.
Thank you.
Thanks.
And next, I support all the previous council members. Indeed, today's discussion was very serious and we received complete answer to all questions. Dear member of council, according to paragraph number 28 of the procedure of the Ministry of Education and Science, and the procedure for a one-time specialized academic council meeting at the General Energy Institute. The word on awarding the Doctor of Philosophy degree in the field of knowledge 17 electronics, automation and electronic communication in specialty 175 information and measurement technology to Denis Anatolievich Katayev is conducted by open vote. Please vote. Yuri Vasilievich puts.
I vote in favor of the candidate.
Thank you. Igor Volodymyrovich Mihachov.
I vote in favor of the candidate.
Thank you. Maxim Alexeyevich Bondarenko.
Yes, I vote in favor of the candidate.
Thank you. Petro Mykolaevich Reiter.
I vote in favor of the candidate.
Thank you. I'm Svetlana Kovton. I'm the head of the council. I vote in the favor of the candidate. Thank you. As a result of open voting, all 5 members of the one-time specialized academic council voted in favor. There are no voted against. In accordance with the procedure of the Minister of Education and Science of Ukraine and the regulation for the meeting of the one-time specialized academic council, at the General Energy Institute, the decision to award the degree of Doctor of Philosophy is considered adopted if it is supported by at least 4 members of the one-time course. The council may adopt a decision by open vote, and based on the result of the open voting in favor, 5 against not, the one-time specialist academic council result as follows. The dissertation of Denisa Katayev, Software and Information Complex for improving the accuracy of measurement of geometric parameters of power equipment parts based on a neural network, submitted for the degree of Doctor of Philosophy in the field of knowledge 17 Electronics Automation and Electronic Communication, specialty 175 Information and Measurement Technology, is a complete independent scientific research works and meets the requirements of the procedure for awarding the Doctor of Philosophy degree, approved by the resolution of the Cabinet of Ministers of Ukraine number 44 of January 12, 2022. Second, to award Denisa Katayev the degree of Doctor of Philosophy in the field of knowledge 17 Electronics Automation and Electronic Communication, specialty 175 Information and Measurement Technologies. Third, the decision of the one-time specialized academic council to award Denisa Katayev the degree of Doctor of Philosophy in the field of knowledge 17, specialty 175, which has been approved by voting, shall be formalized in the accordance with the requirements of the Ministry of Education and Science of Ukraine and satisfied with the official seal of the General Energy Institute. Indicated the voting results of the members of the one-time council. Dear member of the council, allow me to congratulate the candidate and give him the floor for final remarks.
Thank you. Dear colleagues, thank you so much for the opportunity to speak and present the result of my work. The defense is an extremely important area for me, and I am deeply grateful for your valuable comments, questions, and recommendation. I would like to express special thanks to my scientific supervisor for the invaluable support, wise advice, and patience throughout my works. I also express my gratitude of the Institute staff for created favorable conditions for my research. Thank you all for your attention and trust. Thank you.
Thank you. Are there any comments regarding the procedure of today's meeting? No. Thank you. The meeting is hereby declared closed. Now we can stop the recording.